In this lesson, we'll introduce the concept of a variable as a basic tool to save data in our program memory. We'll then show how to leverage variables as a temporary storage for sequences of simple arithmetic computations. And we'll conclude this lesson with a simple strategy to document our code through Python comments. Welcome, and let's get started. Remember the Hello World program we wrote in the previous lesson? Now suppose you'd want to reuse the same Hello World string for multiple purposes, such as printing it several times or passing it in more than just one function call. Typing the same string over and over in your program could be time-consuming and also prone to mistakes. What you can do instead is save that string into your program's memory and access that memory every time you need the string. The simplest method to save data in memory on a Python program is by using variables. A variable is represented with a custom name containing any combination of lowercase characters, uppercase characters, digits, or underscores, with the restriction that the first character should not be a digit. The following examples are valid variable names: age with all lowercase characters, age with the first letter spelled uppercase, name, all uppercase, my_name, or hello123. Notice that variable names are case sensitive. So in these examples, the first two variable names, age starting with lowercase a and age starting with uppercase a, actually represent two different variables. If we need to store a value in a variable, how do we ask Python to create that variable? Well, a new variable is implicitly created in the same line of code in which you assign a value to it. Such line of code is called an assignment, and it has the following syntax: variable equal value. On the left-hand side of this assignment, we find the variable being created, and on the right-hand side, we specify the value assigned to it. What you'll see next are some examples of variable assignments. In each of the following lines of code, we will create a new variable by picking a new name for it and assigning a value to it. Additionally, this time we won't limit ourselves to just using strings. We'll incorporate other data types also available in Python. This first assignment creates a variable named message and uses it to save a value of type string set to hello. The second assignment in the sequence creates a new variable named x and uses it to save an integer value set to 2. Next, a new variable named y saves a real number, also referred to as a floating point number, set to 1.5. Finally, a new variable named first saves a special Python constant called true, notice the capital T, while a new variable named second saves another special Python constant called false, also mind the capital F. These examples highlight a particular property of the Python programming language that sets it apart from other languages such as Java or C++, namely the fact that Python is what we call a loosely typed language. This means that the type of a variable is inferred from its latest assignment, rather than by an explicit type definition for the variable. The same variable, in fact, can be used to store two values of different types at two different points in time during the execution of a program. From the previous assignment, Python deduces the data type of the 5 variables created above as follows. First, variable message is a string, as deduced from the right-hand side of the assignment using the string notation based on single quotes. The string data type is formally represented as str in Python. And even though the formal data type will not be used in this lesson's code, I'm pointing it out now, as this information will come in handy once we talk about data type conversions in future lessons. Second, variable x is an integer value, as deduced from the right-hand side of the assignment containing a number with no decimal point. This data type is formally represented as int in Python. Next, the type of variable y is called floating point, or float. Python distinguishes this from an integer from the presence of the decimal point in the number on the right. Finally, variables first and second are both Boolean values, or bool in Python, as deduced from the only possible Boolean constants, true or false, assigned in each case. Let's go back to our hands-on work now. If you look at the code editor now, and if you completed the work in the previous lesson, you should see a list of all previously created projects, which for now just include the Hello World project. Let's create a new project for this lesson. Click on the New Project button and call the new project Variables. Then press Enter. As before, the project is automatically initialized with an empty file called main.py, where we'll proceed typing our code. Let's start by typing the variable assignments presented earlier. Message equal hello. X equal 2. Y equal 1.5. First equal true, remember the capital T, and second equal false, also capital F. Again, feel free to pause the video whenever you need some extra time to complete these directions. Now we'll use a sequence of print statements to display the values saved in each of these variables as follows. Print message in parentheses. Notice that now the print function takes a variable containing a string as an argument, as opposed to the string itself. The next print call will introduce a new feature of the print function, which is the fact that it accepts more than just one argument if we want to print multiple values in one single line. Multiple arguments must then be separated by commas as follows. Print x, y, which will print the values of x and y in the same line with a space in between. Finally, one last print call will take care of printing the remaining two variables. Print first, second. And this completes our first multi-line Python program. How does Python react to a program that has multiple lines of code? Well, they're simply executed sequentially. The program will start by running the variable assignments one by one, followed by each of the print calls appearing after them, in the same order in which they are given. Once all lines of code have completed, the program simply finishes its execution. But don't take my word for it. Go ahead and try it yourself. Use the toolbar buttons to save the file and run the program. If everything went well, you should see the same program output as shown here. If the output you observe is different, you may have a typo in your code. In that case, pause the video, review your code, and run it until you observe the expected output. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support this channel. Thank you, and happy coding!